That's really. How are you? That's really. Are you good? You muted. I can't hear you. Okay. Let. Thank you very much. Thank you very much. Okay. So now let me quickly explain how we're going to collect that 8 marks. So remember, the reduction formula, the reduction formula is very important, né? Because that part has a lot of marks. So when you do the reduction formula, you need to make sure that you take everything step by step. You're going to look at this pathway. I'm just going to try and reduce everything. So if you still remember, né? You have a Cartesian plane like this. I'm just going to try and draw the Cartesian plane down here. So this is your Cartesian plane. We know that we said all students, they take coffee, or you can say they take cocaine. Ne? So now, in first quadrant, all are positive, right? But I'm not interested in that part. For now, I just need you to know that this is 0 degrees, this is your 90, this is your 180, then this will be your 270. Okay, so there we have 360 degrees. Look at this. Let's first work on reducing the 360 minus theta. 360 minus. So if this is 360 and I minus, I go in that direction. So this tells you that this is quadrant 4. So in quadrant 4, only sign is positive. We're going to reduce this to be the sine squared of what? To be the sine squared of negative sine squared x. I'll show you guys how to write this. Now, so we are saying that sine is negative in that quadrant 4. So I'm going to say this will change into the sine of x. But remember, sine is negative. We still have the squared. So everything should be squared because of that squared. I hope you guys understand how we did that reduction. So when you check the next one, this one has to do with negative angles. You don't have to stress. Nah? So we need to, you see this 180, it's negative. We need to make sure that we put it, the 180, as positive. Okay, so what I'm trying to say is that if I have the cos of x minus 180 degrees, I can write this in this form. I can definitely take the negative out as a common factor, and this will leave me with what? 180 minus x. I'm not sure if you guys understand taking the common factor out. I'm not sure if you guys are happy with that. Do you understand how this works?
Yes, sir.
Yes, sir.
Okay. Or alternatively, someone can
Yes.
prefer, someone can just say, instead of
And
taking
at
negative out as
60.
a common fix, as a common factor, we can definitely add 360. You understand? So we can write this thing as the cos of x minus 180. Then you add 360. I think this is the easiest way to do this because can someone assist me? 180 plus negative 180 plus 360, that's positive 180, right? So this guy can be written as the cos of 180 degrees plus x. Then you're gonna check how is 180 plus x in quadrant 3, because when you add 180, you'll approach 270. That gives you quadrant 3. How is cos in quadrant 3? Cos is negative. So this will be negative the cos x. So now I'm going to subtract inside the bracket negative the cos x. That will be the reduction for that guy. Therefore, negative angle is in quadrant 4. Negative theta, that one is in quadrant 4. Then you're going to ask yourself, how is tan in quadrant 4? Tan is negative, so this will change into negative the tan x. Then you do the same for this one. This one is a it's a cofunction, okay? This one, it's a cofunction. So when I say it's a cofunction, sine changes to cos, cos changes to sine. First thing first, you check, where is 90 minus? So if this is 90, you are subtracting, will approach 0. So 90 minus, it's in quadrant 1. How is sine in quadrant 1? Sine is positive. Therefore, this will change into positive, the cos x. If this is sine, sine changes to cos. How do you see that? Because of the 90. 90 degrees, that tells you that this is a cofunction. So I'm going to multiply this by the cos of x. This will be multiplied by the cos x. Then let's reduce the last one. Who can tell me what is the cos of 360 plus x? When you reduce that, what do you get? Anyone?
Cos x.
Cos x. Thank you very much. So this will be the cos of x. Therefore, everything is divided. We're going to divide everything by the sine of 180 plus x, which needs to be reduced also. 180 plus, that's quadrant 3. How is sine in quadrant 3? Sine is negative. This changes to negative the sine x. Okay, let's work this thing out. Now, remember, if I have minus a squared, it's just a squared. So this will be the sine squared. So this is just sine squared x. And then these two negatives, they will cancel. Negative and a negative, they will cancel. And then this negative will cancel which one? The one in the okay, I think if I do it like that, maybe someone might be confused, someone might be like, and then what is going on here? You know what I'm going to do? So what I'm going to do is that I think even this thing, when I write it like this, is going to be incorrect. Look at this term here. You see, this is a separate term to that sign. So sign is not over anything. So I just have to fix that here. Sign is not over anything. So I'm just going to remove that part. So if that's the case, this will make everything to be easy because we know that the 2 will cancel, and then this negative and negative, they will give us positive. Negative divided by negative, that's positive. Therefore, cos times, what is this? I'm just going to leave the cos x as positive, and then let's change the tan into sine x over the cos x. Then close the bracket. This is multiplied by the cos x times, okay, let's just say the cos squared x. So I'm just going to multiply the two guys. I'm just going to multiply this cos and that cos, which will give us the cos squared x. Then everything is divided by positive sine x. This cos and that one cancels. We are left with what? We are left with sine squared x plus sine x times the cos squared x over what? Sine x. Can I take out the common factor on top? Yes. So I'm going to have sine x out as a common factor. This leaves me with sine x. Sine x plus what? Wait, let me just look at this. You see, I'm doing another mistake again, guys. I hope you guys are with me now. Do you see the mistake that I'm doing here? This tells me that you guys don't see the mistake. You were supposed to correct me. Remember, this is division only for that part, not for the sine squared. The division should only be for that term. I hope you guys understand. Please, when you see a mistake, you need to tell me now. So this is over sine x. So this tells you that this sine x and that sine x will cancel. which leaves us with sine squared x plus the cos squared x, which is equal to 1. That's the final answer. Are you all happy with that?
Yes, sir.
Let's talk about the mark allocation now. So you need to check the reduction formula that you did. There's a 1 mark for that one. There's a mark for the negative cos x. There's a mark for negative tan x. There's a mark for cos x. And for that cos x, there's a mark for this one. So far on this step, you have 2, 4, 5, 6 marks. Right. And then they'll definitely give you the mark for simplification, the mark for getting the cos squared plus sine squared, and also the mark for the final answer. That's how you collect the 8 marks. Right? And that's it for this one. Let's move to the next question. But before that, you guys have any question on this one?
No, sir.
Okay.
Also,
So now they say that on 3.2, they say if beta is an element of 90 degrees and 270. So this is an interval, and negative 90 and 270. We'll definitely talk about that interval. Determine beta without the use of a calculator. Another big mark there. Let's go and work on this one. We need to solve the cos of beta plus 8 degrees. Okay, let me just rewrite the equation down, then we'll take it step by step. Remember, we are given beta. The interval, they said beta must be an element of minus 90 degrees and 180. And then we need to solve the cos of beta plus 80 degrees. This is equal to the sine of minus 300 degrees. And then the cos 45 degrees. Everything there is divided by the cos 405. Okay, so I'm just going to leave the beta for now. I'm just going to work on my right-hand side. But now, this guy, it's a negative angle. Remember, we just said the negative theta that's in quadrant 4. How is sine in quadrant 4 negative? So we can write this as negative the sine of 300 degrees before you reduce it. And then from there, you can definitely reduce it, or you can just add 360. So when you reduce this, you're going to check in which quadrant is 300. That's quadrant 4, because it's between 270 and 360. So this angle is in quadrant 4. So this will be negative the sine of 360 degrees. You ask yourself, what should you minus to 360 to get 300? Can someone tell me? What are we going to subtract here?
60.
60. Right. So if we subtract 60, now we can do the reduction formula. 360 minus theta, that's quadrant 4. How is sine in quadrant 4? Sine is
negative.
Exactly. So this will give us something like negative into negative the sine of that angle. Okay, so negative and a negative, it's a positive, which gives us the sine of 60. So this tells you that sine of that negative angle, we can definitely reduce that into the sine of 60. And I'm happy about that because I know that 60 is a special angle. Therefore, I need to work on reducing the cos 405. Remember, you check where is 405? That's quadrant 1. Because if I say 360 degrees, then I add, what should I add to this one to 360 to get 405? I should add 45, which is quadrant 1. So 360 plus theta, that's quadrant 1. So we can write the sine, not the sine, the cos 405 to be the sine of 360 plus that angle. So now sine is positive in quadrant 1. This will change into the sine of 45. Then you're going to divide that by the sine 45. Oh, I'm sorry, the cos 45. How did we get sine? This should be cos, this should be cos. So we're going to divide this by the cos 45. You guys understand how I did that reduction formula? Are you all happy?
Yes, sir.
Yes, sir.
Okay. So now, you can definitely go to your calculator. And okay, before you calculate, you can see that the cos and the cos cancels. I'm left with sine 60. Therefore, if we go back, let's go back to that question. The question said, without using a calculator, can someone please say sine 60 on the calculator? Tell me what you get.
3/2.
Root 3 over 2. So how do they know if you use the calculator?
They wouldn't.
Okay, it's fine. We'll talk about that part where they know that you use a calculator. So now, most of the time you can punch this on the calculator and it will give you this root 3 over 2. So you just have to show all the steps. When they say without using a calculator, they need to see all the steps, then I'll definitely show you guys again how they see that you use the calculator. Ladies and gents, if your answer, when you look at this, we know that left-hand side is the cos of beta plus 80 degrees, and this is equal to the root 3 over 2. Ladies and gents, tell me, how should we solve for beta here? What is the next step? Yuhen, what do you think? Because if the question said, if beta is this, determine beta. What should we do? Anyone? You guys know what is the next step? Nothing. You guys don't know how to solve for x. How can I isolate beta here?
S transpose.
Who's
I'm
this?
thinking.
Reatlerile. Is it reatlerile? Karabo, what do you think?
See, I'm not sure. I'm thinking we should transpose ish the 80.
Okay.
And then
Transpose the 80. How can we transpose the 80 while it is closed inside those brackets?
I don't know what to do then say in this case or in this instance.
Yuhan, do you have a plan? You did this thing in grade 10. Reatlerile, do you have a plan? This is something that you guys did in grade 10. Remember, in grade 10, we said that to solve for theta or for x or for beta, whatever angle that you're looking for, you get rid of this cos. To get rid of this cos, beta, in fact, not beta, your reference angle, you find what we call reference angle by saying the cos inverse. So to get rid of this cos, and it's like saying you divide both sides by cos. Therefore, this will give you your reference angle. It will be the cos inverse of that value, the root 3 over 2. You just have to punch your calculator and tell me what is the cos inverse of root 3 over 2. What is your RA? What is your reference angle?
30.
30 degrees, right? So now,
Yes.
remember, reference angle is 30 degrees. And we are looking for beta. I still have 80 degrees. So I'm going to equate this to what? Listen, this is one of the most important part that we're going to work on. They said that theta must be between minus 90 and 180. Okay? So you're going to first take your reference angle, which is 30, then you add k times 360. I see someone is, let me quickly go to the chart. Or maybe someone raised a hand. Let's see, what do we have here? Did you?
Yes, it was me, sir.
Okay, I'm listening, you had.
Please, sir, so this is a calculator question, right? So how do you
Is it?
punch this on the calculator? You press cos and then the x with the -1 sign.
You're gonna say shift cos. You want to understand how we got the reference angle?
Oh, okay, yes, I got it.
Shift. You're gonna say shift, then you press cos, ne?
Yes. Okay, thank you, sir.
All right. So now, listen. Let me go back and teach you how to be smart, ne? You see this question. When you see they say solve for something and they give you this interval, the interval is telling you that this is a general solution. So they don't say directly solve for general solution of this equation. They just say beta if theta is an element of what. This is a general solution. And it is a general solution. You have the reference angle. And since you have the reference angle, you can just go and put your reference angle there. You add k times 360. But we are looking for beta, meaning the 80 will come this other side to be negative, which gives us 30 minus 80. That's minus 50. So the final answer is minus 50 degrees plus k times 360. Guys, the solution that you see on the board, this is for quadrant 1. This is for quadrant 1, okay? Because the cos is √3/2. It's positive. Then you're gonna check where it's cos positive, quadrant 1 and quadrant 4. Then now we need to work with quadrant 4. So what should we do with quadrant 4? Look at this. In quadrant 4, this will be 360 minus reference angle, which gives us 360 minus 30, that's 330. 330 is not in that given interval, so I'm not going to work with quadrant 4. But remember, I'm not going to work with quadrant 4. Remember, this 30, it should be plus or minus. So this tells you that on another reference angle, it will be negative 30 degrees. So we need to work if we have negative 30. Then you do the same. Beta plus 80 degrees is equal to negative 30. You add k times 360. So the 80 comes this other side to be negative. That will be minus 30 minus 80. It's 110. Minus 110 degrees plus k times 360 degrees. Okay, so now when you do this, that's your beta. Then you're going to say beta is equal to that. Okay, look at this. Minus 110 is still not in that interval. It is not in that interval. So now, look at this. Look at this, guys. I need your attention on this one. When you solve for general solution and you are given the interval, this is not where you stop. You're going to use these two equations here. You see this equation? You're going to use this answer and that answer to find the exact value of beta. I'll definitely work on that. So I'm going to test if k is 0. On this equation, where does k we put 0? What is beta equals to? That's minus 50, then plus 0 into 360. This is beta is just minus 50 degrees. Then you check, is minus 50 in that quadrant, in that interval? Yes. Minus 50 is between minus 90 and 180. So I'll definitely take that answer. So once you get that answer, you're going to look for the answer on the next part, on this next part. You test for if k is 0, if k is 1, if k is 2. If it's not working, you test k is -1, k is -2. So if you get one answer this side, you're done, you move to the other one. Then now look at this. If k is 0, we get -110. So that won't work. 0 won't give us the answer that is between -90 and 180. So that one won't work. Then you test for 1. Okay, so if this is 1, you're going to get 360 plus what? 360 plus, what is that equals to? 360 plus 180. No, 360 plus -110. What do you guys get? What is your answer? Guys, -110 plus, where there's 1, we put 1, 360. You just have to add the 2. -110 plus 360. What is your answer? Anyone?
$250.
250. So I can see that 250 is not in that interval. It's not between -90 and 180. I won't take 250. Let's try 2. So even 2 won't work. So I'm just going to give them this one answer, and then I'll definitely get the mark. Don't worry, man. You'll definitely get the mark even if you write that one answer. I'm not sure. You guys understand how this works?
Yes, sir. Second, I ask
Okay, I'm listening.
for the reference angle. In the first case, we used the first quadrant, and then Sir said in the second case, we can't use the fourth quadrant because it's not gonna give us the angle that is required. So we have to use the opposite sign of the reference angle.
Yes.
Is that how it's supposed to be every time if we see that our answer is not going to be in the given interval?
Exactly. That's what you need to do. If you check in most of the previous memos, they will say that your reference angle is plus or minus 30.
Yes,
Then you know what I need you guys to go to your Google and search why is the reference plus or minus 30. Then they'll definitely explain it to you. Why is it? It's always plus or minus. So now I'm not saying that in all your solution include plus or minus, but when you're working with the interval, try to also check when it's negative. But if they don't give you the interval, just stick to your reference angle that you got, solve it, give it to them, then you'll definitely get the marks.
Yes, sir.
Okay, should we move to the next question?
Thank you, sir. Yes, sir.
Okay. Okay. Look at what we have now. Determine the value of the following without a use of a calculator. Guys, this looks like it's easy, né? The 3.3.1.
Yes,
So when I look at this, I can use look at this. Can you say on your calculator, say 90 minus 49? Tell me what you get.
41.
41. So this tells me that I can say the sine, I can write the top part as the sine of 90 degrees. Then what should I subtract to get 49? I need to subtract 41. Then let me leave the bottom part as the cos of 41. Because since I have 90, this is a cofunction. The top part, it's in quadrant 1, sine is positive. This changes to positive, the cos of 41, and then over the cos of 41. So these two cancel, they just give me 1. That was easy, né? Right, look at this. The sine of 85, cos 85. Cos 65, sine 65. This is a compound angle. You have sine, cos, cos, sine. Sine, cos, cos, sine. Then you go to your, what is this? To your formula sheet. I'm not sure if we have the formula sheet. Okay, there. We said we have what? We have sine, cos, cos, sine. Okay, so look at this. We have what? We have sine, cos, cos, sine. The angles are the same. This is a compound angle for sine. You're going to say, remember, this was 85, né? 85 and this was 65. Alpha is 85, this was 65. So we can write this as the sine of 85. We add it to 65. Then we can start working on that. Are you all happy with that?
Yes.
You guys understand? Okay, so we can rewrite this equation as the sine of 85 plus 65, and then this will give us the sine. You add the 2, 20, that will be 100, then this gives us what, 15, eh? Okay, let me just say 90 plus 60, so that will be 150. So this will be the sine of 150. So you need to do the reduction formula. 150, that's quadrant 2. So this is the sine of, in quadrant 2, that's 180 minus, what should we exactly? We need to subtract 30. So how is sine in quadrant 2? Sine is positive. This changes to the sine 30. And on your calculator, you'll find that sine 30 is half. Then you're done. Okay. When I look at this one, the next one, the last one. So this one, there are many ways that you can work on the problem, but let me try to choose the best way. Can we please first multiply out the bracket by 1/2 and see what we get? Look at this. 1/2, the cos 15 degrees, plus 1/2 times that will give us √3/2, the sine 15. So when you work with trigonometry and then you are simplifying, check if you have related equal angles. So when you see equal angles, what should come in your mind? The compound, what is this? The compound, what can I say? The compound angles, okay? So now, if you go back to what we solved previously, let me quickly go this side. If you go back, we got the sine of 60 to be √3/2. Okay, so this tells you that if you are very, I'm not sure, like very quick when it comes to thinking, you can see that, oh, I know that the √3/2, it's coming somewhere. So this √3/2, I know that this will be the sine of 60. Then, since this is 60, even this one should have 60, but it should not be sine, it should be cos. Because remember, compound angle, it's cos, cos, sine, sine, or sine, sine. So since I have both of them this side as sine, look at this. Already we know that this will be the sine of 60 times the sine 15 degrees. So you know that since you have sine, sine, according to your compound angle, you have sine, sine. Next, you go to your formula sheet, you check. Look at this. Sine, sine, where is it? Okay. I think cos, cos, sine, sine. Sine, 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 then cos, cos. So the other one should be cos. Remember we said this is sine 60 times the sine 15. So this tells you that beta On this one, the cos should be 15, and then this one, the cos should be 60. So you have to check what is cos 60. Then cos 60 should give you half. So where there's half, you put the cos 60. You understand how this goes? So this tells you that where there's half, you can have that as the cos of 60 times the cos 50, so that we can reduce this thing and write it as the cos of, since it's for cos, this will be 60, the sign changes from positive to negative, which will give us the cos of 45. Then you punch that 45 on your calculator, you'll find your answer is root 2 over root 2. Don't substitute that. Instead, rationalize your answer. Okay? Guys, tell me you understand how I answered this question.
Yes, sir.
Yes.
Are you sure you guys understand what I did?
Yes.
We first multiplied out the terms by 1 over 2. Then we can see that no, man, root 3 over 2 is coming somewhere, which is sine 60. So since this is sine, we're going to look at our compound angle. We can see that, oh, this is compound angle for cos. So if it's sine, even this side we should have cos. So if it's 60, 15, this side should be 60, 15. Then this tells you that the 1 over 2 is cos 60. You reduce this and write it as the cos of the first angle, which is 60, minus the other one, which is 50. To avoid having negative 1, we start with this one, with the first angle. 60, you minus the second angle, which is 50. Cos 45, that's root 2 over 2. Then that will be your answer. You can rationalize that and give it to them.
Okay.
You guys understand? Mm-hmm.
Yes, sir.
Okay, so yeah. Now let's see. I need you guys to, this one is a general solution for 6 minutes. Can you guys please work on this 4.1? Let's see what you get. Please guys work fast so that I can give you the solution for this 4.1. Ne? Can you please quickly work on this 4.1? Then
Yes,
we'll
sir.
discuss the solution for that. Ne?
Yes, sir. Yes, sir.
What's your answer you have? What did you get? What's your answer? Karam, what's your answer?
You say I'm not done.
Okay. We just only have 10 minutes in this lesson. Let's quickly work on this one together. Ne? You were given the cos 54. And the subtract x, this is equated to the sine 2x. Ladies and gents, when you work with general solution, make sure that if this is cos, make sure that this is also cos. So my question is that, how can we change this to be cos? Can someone tell me? What should we do? What should we write?
Cos. It's going to be cos 90 minus 2x.
Exactly. Thank you very much. So this will be the cos of 90 degrees minus 2x. Because if we do the reduction formula, we'll say 90 minus theta, that's quadrant 1. Cos is positive. This changes into sine of 2x. So this is the cos 54 degrees minus x. Since it's cos, you drop the cos. Then you're left with 54 minus x. This is equal to 90 minus 2x. Therefore, after dropping the cos, you're going to say where you, on this side, where you have the 90 minus 2x, you add k times 360 degrees. So you see, if you get a general solution like this will be your lucky day, because this one is the easiest one. Eh? Then you're going to group the like terms. So how do we group the like terms? Easy. Okay, so to group the like terms, I'm going to move the 54 this side to be negative, the 2x this side to be positive. So this will be minus x plus 2x. It's equals to 90 degrees u minus 54 degrees plus k times 360. Then minus x plus 2x, that's x. Therefore, what is 90 minus 54? 36, right? Plus k times 360, then that's your answer. That's your general solution. Listen, are you guys still with me?
Yes, sir.
Yes, sir.
Listen, someone asked, let's fix that negative part. Remember I said, you see this thing, né? This angle here, it's your reference angle, meaning that you can choose to say it's plus or minus, meaning the other one that will be negative is going to be negative 90 minus 2x. Multiplying out the bracket will give us minus 90 degrees plus 2x, meaning that the other solution will be 54 degrees minus x. It's equals to minus 90 plus 2x plus k times 360 degrees. Then from this, you can definitely bring the 54 to the other side. So I'm left with minus x minus 2x. It's equal to minus 90 degrees minus 54. Then we add k times 360. So minus 90 minus 54, that will give us 144. So this will be negative 144 degrees plus k times 360, and then minus 3x, divide everything by negative 3. Everything by negative 3. So the final general solution, okay, you know, I'm thinking of doing something here. Okay, so this will be x is equals to positive 3 goes into 144, 48 times. So this will be 48 degrees minus k times 120. K times 120. 120 degrees. Then that will be your answer. I just want to verify if we are allowed to divide the k times 360 with a negative sign. Are we allowed to do that?
Yes, sir.
Okay, thank you very much. And that's it for this one. That's it for this one. So for your homework, go and practice this 4.2. Just take a quick screenshot, do 4.2 without using a calculator, and use the aid of a diagram to work out that question, okay? Go and practice that question. I'm going to give you tips how to do this. First thing first, isolate sign. So to isolate sign, you bring the 5 this side to be minus, divide by 13. Then draw the diagram in the correct quadrant. Find the missing value. If you have x and y, find r. If you have r and x, find y. Then find the value of sine 2x. Sine 2x is 2 the sine x times the cos x. That's your homework. Go and practice that one. And that's it from me. This is where we're going to stop for today. You guys
Okay,
have
sir.
any questions?
Could you please just send me the note?
Everything that we did today.
It's just all that you've written down.
What about the recording?
No, I'll just take on the notes. It's good.
You want me to send you what?
The notes.
Oh, okay, no problem.
Yeah. You could just screenshot it and send it. Thank you, sir.
Okay, sure, thanks.
Okay. Bye, sir.